Alright guys, welcome to Vectors, which happens to be chapter 12 in your book. Take a moment please, hit pause and copy down this information and then we'll talk about it. Alright, so this chapter is titled Vectors, so we had better start by identifying what a vector is. So it's a quantity that has two things. It has both magnitude, which is a fancy word for size, as well as direction. Now, a very common example is velocity. So let's define velocity. We're going to see it several times, not only in this unit, but also when we study calculus. Velocity refers to the rate at which something changes its position. So if we jump down here for a moment, we can say that a car has velocity of negative 70 miles per hour. Now, the negative part of it is referring to the direction. Maybe the car is traveling on the thruway and it's heading west, which we can indicate that as being a negative direction, okay? Whereas east, let's say, is a positive direction, all right? We also have the speed component that goes with it. We wouldn't say the speed is negative 70 miles per hour. Of course, we would just say the speed is 70 miles per hour. So here's an important formula to keep in mind. This is not given to you. Speed is always going to be the absolute value of velocity. So let's now go back up here and look at our other definition of a scalar. A scalar is another quantity, but this time it only has magnitude, so there's no direction associated with it. An example is speed. Alright, so speed we know refers to how fast something is traveling, okay? So there's no direction associated with speed itself. If we look at velocity, yeah, that's a vector because there's both a direction that you can be heading as well as the speed at which you're traveling, okay? Alright, we're now going to look at how we represent vectors. So there's two different forms here that we're going to talk about. One is called column vector form and the other is called unit vector form. So to kick this off, let's suppose we have point A, which is at the origin, and suppose this is where we're starting our travel. And suppose we want to end up at point B, which is at the point 4, 6. So knowing that, we can draw in a vector, all right, which really looks like a ray. This arrow at the end of it is showing us the direction of our travels. So you'll hear me talk a lot about thinking of vectors in terms of traveling. So we're traveling down a certain path from A to B, and we can see the direction here. So it's important to understand that we're going from A to B, not from B to A. So we can represent this vector as AB with an arrow over it going to the right. You're always going to have the arrow going to the right, even if you're moving to the left. The symbol is to always draw the arrow above going to the right like that. Understand that the first letter is your start, and the second letter, the second point, is your end. All right. And so we can express this in what we call column vector form. And what that means is we're going to be looking at the x and y components. So if you were to make a right triangle out of this, okay, this is what we call the x component, and then this is what we call the y component. Okay, makes sense because x is horizontal, y we know is vertical. So we can see that the x movement is to the right 4, and the y movement is up 6. So to write this as a column vector, what we do is it looks like a big parenthesis, and we're going to put the x component up top and the y component on the bottom. So let's just jot down that this is really the x and the y component. So the x component we call the horizontal component, and the y component we call the vertical component. Notice this is not a fraction, it's not 4 divided by 6, it's 4 on top of that 6. So when we express our vectors in column vector form, okay, so it's a column, right? So you then have the x up top, and then you always are going to have the y in the bottom. Now, getting back to this AB notation for our vector, please understand that this vector AB is not the same as the vector from B to A. Vector BA would start at B and end at A. So the magnitude or the length of this vector would be the same, but the directions are different. Okay, so if we were to find the magnitude of this vector, the symbol for this is an absolute value symbol. So if I take my vector AB and put it inside of the absolute value symbol, that again is just a symbol for its magnitude or its size. Well, you're simply going to use Pythagorean theorem to find that length of your vector because we really have a right triangle. So we would really end up with the square root of 4 squared plus 6 squared. So the square root of 52 would be the length of that vector. Of course, you can turn it into a decimal, but radical 52 would be the exact length of that vector from A to B. All right, now the magnitude of this vector, if we were to reverse it, the magnitude of vector BA would still be the same as the magnitude of vector AB, but again, the direction would be different. Okay. Another point to emphasize. I mentioned earlier that this kind of looks like a ray. Well, rays go on forever, whereas vectors have a clear start and a clear end. So at the tip of that arrow, that is where it's ending. So it doesn't go on forever in that direction. Okay. Let me just add here too that when we say column vector form, sometimes we just call it component form because we can clearly see the x and the y component. Now, sometimes you may see vectors represented with a lowercase bold letter. So perhaps we want to call this vector AB just lowercase c. So I'll try to make this look bold. Okay. So on the picture, you would see it labeled right in the middle, all right, somewhere between your start and your end point. So sometimes a lowercase bold letter will represent your vector. All right, okay, and so the other way that we can express vectors is called unit vector form. And there's a couple basic definitions here that you have to keep straight. We introduce a couple lowercase letters. We have an I and a J. So the I, by the way, has nothing to do with the imaginary I symbol. Okay. Vector I, which we call a unit vector because it has a length of 1, right? 1 unit. That's why it's called a unit vector. This is really the vector 1, 0. So the x component is 1, the y component is 0. This would be a vector that is exactly 1 unit to the right. Okay, so there's really a distance of 1 there. Whereas j, we define this as another unit vector. So again, a vector with a length of 1, but this would be exactly 1 unit in the positive y direction. So getting back to my vector 4, 6, right, the one that we called AB, all right, with components 4 and 6, we can say that this is the same as, well, if we focus in on this 4 for a moment, a distance of 4 to the right, well, that would be 4 i's, right? Remember, an I is simply 1 unit to the right, so we need 4 of them, plus, if we have 6 for our vertical y component, we would have to go up 6. So we would need 6 j's. So usually I encourage people to write vectors in component form as opposed to unit vector form, but you might see some questions that ask you to write it or express it in this so-called unit vector form. So unit vector form simply means you need i's and j's. Okay? Understand that the I is really referring to the x component and the j is really referring to the y component. Okay, next example here. Suppose we have a point 1, 2, which we're calling E, and we are starting our vector there, and we're ending at point F, which is at negative 6, 10. And suppose we want to express this vector using both forms. So vector EF, remember the arrow is always going to the right. If we were to express this in component form, what we really need to do here is make a right triangle around it and figure out what the x and y components are. Well, the distance from the x value of 1 to negative 6 would of course be 7, right? If you need to graph it, go ahead and graph it, all right, and count your blocks, but I'm sure you can figure out that that distance there is 7. And then the vertical distance between 2 and 10 would be 8. So the x component is, well, we would think it would just be 7, but we're moving to the left, right, in the negative x direction. So it would need to be negative 7 for the x component. And then since we're going straight up, the y value is positive, so that would be 8. Now, if we were to also express this using unit vector notation, this is the same as negative 7i plus 8j. Okay? And if we were to find the magnitude of this vector, okay, it doesn't matter which form you use. I suggest you look at the component form because we're really after the numbers of negative 7 and 8. We're just going to put those into Pythagorean theorem. The vector is really the hypotenuse, right, of Pythagorean theorem. So that would give us a square root of 113, which if we fed it to the calculator, it's approximately 10.6 in length. Okay, so that's the magnitude or the length of that vector. Notice how the negative, when we put it into Pythagorean theorem, it gets squared, so we don't really care about the direction part of it.